Substitution problems. Our question says, the amount of money in Jenny's pocket, J, and the amount of money in Benji's pocket, B, are represented by the following equations. Calculate how much money each person has. So our two equations are 2 times J plus 3, take away 3B, equals 46.25, and 3 times 3J plus 7, take away 2 times 4J minus B, equals 43.75. So the question is asking us to solve for both B and J. We're given two equations with two unknowns, and we need to solve. So it's mentioned in the question here in the title that we're going to be using substitution. So substitution is a good way to find where two lines intersect. And believe it or not, even though these don't have an X and a Y, they have a J and a B, it's still a line equation. So what I want to do is use substitution. So I'm going to take the two equations and write them down side by side. So I have 2 times J plus 3, take away 3B, equals 46.25. And the second equation, we have 3 times 3J plus 7, take away 2 times 4J, take away B, equals 43.75. So when you're solving by substitution, what you want to do is take one of the two equations, rearrange it for either J or B, and substitute it into the other one. So when I'm trying to decide which one to rearrange, I usually look for a J or a B that has no coefficient. But right now I also notice that I have some brackets and I actually have multiples of some terms. So I think in order to make a good decision, I need to first expand out my equations and simplify them before I can decide which one I want to rearrange and isolate. So I'm going to take the first one and multiply the 2 into the bracket. So 2 times J is 2J. 2 times 3 is positive 6. And then I still have a take away 3B equals 46.25. So if I take a look at the terms on this side, I don't have any like terms. We have J, we have B's, and we have just a plain number. So none of these are like terms, so I cannot add any of them together. But I could move that plus 6 to the other side by subtracting 6, just to make this look a little neater. So I get 2J, take away 3B, equals 40.25. So if I take a look at this equation, I notice that the J and the B both have coefficients, so I really don't want to have to rearrange for either of those unless I have to. So I'm going to try taking a look at the equation, the second one, and see if I multiply it out whether I get a letter without a coefficient. So I'm going to multiply the 3 first. 3 times 3J is 9J. 3 times 7, 21. Negative 2 times 4J is negative 8J. And negative 2 times negative B is positive 2B. And that still equals 43.75. So if I look on the left side for like terms, I do notice that I have a 9J take away 8J, which would leave me with just 1J, or I can just write that as a single J. And then the 21 and the 2B are not like terms. And that still equals 43.75. So I'm going to do the same thing I did with this one. I'm going to take that 21 to the other side. And I get J plus 2B equals 43.75, take away 21, which is 22.75. Now, when I take a look, this one, there were coefficients in front of the J and the B. Here, I have a J that does not have a coefficient. Well, it has a coefficient of 1, but that doesn't have a number really that I can see there. So what I'm going to do is isolate for this J by subtracting the 2B from both sides. So I get J equals 22.75 and 2b are not like terms. This one has a b, this one does not. So it's going to say 22.75, take away 2b. And I'm going to take this equation, and everywhere I see a j in the other equation, I'm going to put in 22.75 take away 2b, since j equals 22.75 take away 2b. So in place of this j, that's what we're going to put in. So I'm going to rewrite this. I've got 2 times, and instead of the j, we're going to put in 22.75 take away 2b, take away 3b, equals 40.25. And then now I have an equation that I can solve, right? We have numbers, we have b's, we only have one variable, so we can solve our equation. I'm going to do that by multiplying out the bracket. So 22.75 times 2 is 45.5. 2 times negative 2 is negative 4b. Take away 3b equals 40.25. So what I want to do is look for like terms. I have a minus 4b and a minus 3b, which will combine to give me negative 7b. So I have 45.5, take away 7b, equals 40.25. So now what I want to do is solve for b, and I'm going to start by moving that 45.5 to the other side. I do see that there's a subtract sign in between these, but that subtract belongs to the 7. And the 45 is actually a positive number. So to move a positive 45.5, we're going to subtract 45.5. And I'm left with negative 7b equals negative 5.25. So to finish solving for b, I need to move that negative 7 to the other side. We're currently multiplying, so we're going to divide by negative 7. I'm going to use my calculator to help me with this. Negative 5.25 divided by negative 7 is 0.75. So b equals 0.75. If I look back at the question, b was how much money Benji had in his pocket, which means that Benji has 75 cents in his pocket. But I still need to figure out how much money Jenny had, so we're going to use the other equation, the one that we rearranged, and put in 75 cents for b, and see if we can calculate how much money Jenny has. So j equals 22.75, take away 2 times 0.75. Okay, we're going to use order of operations. Multiply first. So 22.75. Negative 2 times 0.75 is negative 1.5. So 22.75 take away 1.5 is 21.25. Which means that Jenny has $21.25 and Benji has 75 cents. So if you just have two equations, we usually just write the solution is and we write it as a point. But since this has context, right? J is how much money Jenny has in her pocket, B is how much money Benji has in his pocket. We need to write a sentence. So I'm going to say, therefore, that's the 3 dots, Jenny has $21.25 and Benji has 75 cents. And that's substitution problem.